3.4 rational zeros of polynomials. So that's what we're going to be talking about, is trying to find all the zeros of polynomials. So let's learn a theorem. So if you have a polynomial with different integers, what you have to do is find all the possible rational zeros. And the theorem says if we look at basically the last term, and then the first term, and we're going to take p divided by q of all those possible factors of those terms. So that's where it says where p and q are integers. P is a factor of the constant a naught, a of 0. So you have that last one. So all the factors of that last one is the top one. And all the factors of a of n, so the very first one. So that's what the rational zeros theorem says. So let's look at this. It says this is our plan of attack. So when I give you a problem, a polynomial division, here's your plan of attack. So list possible zeros. So that's the first thing you're going to do using that theorem. And then you're going to start using synthetic division and keep doing that until you get a 0. And then once you get a 0, then you repeat it until you can factor it all the way down to a quadratic, and then you can find all of the factors. So you list the possible zeros, you use synthetic, and then you repeat the process until you're done. All right, so first if we write this polynomial in factored form, so and then find all the zeros. So we're going to use synthetic division with 2, 1, negative 13, and 6. But what numbers do we use? Well, notice the factors of p. Remember, your last term is p, and your first term is first coefficient is q. So all the factors of p would be 1, 2, 3, and 6. And again, I had to put positive and negative. Those are all my possible factors. And then q, the possible 2 would be possible 1, possible 2. So p divided by q, so I'm going to take p, each one of the values of p, and divide it by each of the values of q. So 1 divided by 1 is 1, it's plus or minus 1, and then 1 divided by 2. So again, I'm starting with this, and I'm dividing it by both of the q's. So 1 divided by 2. And then I'm going to go to the next one, 2 divided by 1. I'm just going to write 2. I mean, 2 over 1 is the same as 2. And then 2 divided by 2. Now, when you take 2 divided by 2, that's the same thing as 1, and I already have 1 listed, so you don't need to repeat that again. And then I'm going to go, so I'm going to go to 3. So 3 divided by 1 is 3. And then 3 divided by 2. And then I'm going to go to 6. 6 divided by 1. And then 6 divided by 2. But 6 divided by 2 is the same as 3, so I don't need to list it. So these are all my possible zeros that could be taken out of there. So what we're going to do is if you're a good guesser, this is great. So you would literally just pick one of these and then see if it equals 0. So I'm just going to randomly pick one. I'm going to start with positive 1. So if I bring this 2 down, and then 1 times 2 is 2. And then add, so I'm going to just multiply, add, and see if it's a 0. So 1 times 3 is 3, this is negative 10. 1 times negative 10 is negative 10, and then this adds to negative 4. So this positive 1 is not a 0. And then you could try negative 1. And by the way, I would suggest keeping track of it. Remember, we talked about it in the last section. Whenever you use synthetic division, the remainder theorem says if the remainder that we got here is negative 4 is the remainder, that's the same thing as if I plug 1 in. If I plug 1 into that function, that's the same thing as getting the answer of negative 4. So just keep track of which numbers you plug in, because I've seen a lot of students is what they'll do is then they'll just erase it, and then they forget which numbers they've tried before. And so you're going to literally have to try a bunch of these until you find the zeros. And really all we really need to do is find 1, 0, and I'll show you why in a minute, because we just need to get it down to a quadratic. So I'm going to try negative 1 next. So 2, 1, negative 13, 6. I'm going to bring 2 down. Negative 1 times 2 is negative 2. And then negative 2 plus 1 is negative 1. And negative 1 times negative 1 is positive 1. Negative 13 plus 1 is negative 12. Negative 1 times negative 12 is 12. And that's 18. So again, negative 1 gives 18. But again, it's not a 0. I'm trying to find out which ones are 0. So what number to use next? So I typically do all my nice numbers first, like 1, 2, 3, 6, and then I go back and try the fractions. But just because it's a little bit easier math doing it that way. So I'm going to switch to, I'm going to go to a 2, even though I went from 1 to 1/2 here, but I'm just trying all of these numbers to see which one will work. So I'm going to go to 2. So we're going to bring 2 down. So 2 times 2 is 4, add that together. 2 times 5 is 10, add that together. 2 times negative 3 is negative 6, and notice I got a 0. So when I put 2 in, I have a 0. Now, the reason why that is interesting to find out, so remember, once I find a 0, what remains, so this is the coefficient. I started off with x cubed, so this is going to be 2, this is the coefficient 2, x squared, then 5x minus 3. And so what I just found, 2 was a 0, so x minus 2 is a factor. So I just now factor that, and then what you can do now, once you get it down to a quadratic, then you can factor it by yourself without doing synthetic. You can keep trying synthetic, and you will find all the zeros if you want, but once you get it down to a quadratic, it's a little bit easier to do that. So once we factor that, we end up getting this. So I found I factored it, and then the zeros, x equals 2 is a 0. This will mean x equals 1/2 is a 0, and x equals negative 3 is a 0. So again, and all of those are listed. I mean, 2 is listed, 1/2 is listed, and negative 3 is listed. So, you could keep using synthetic, and you would find all of those. You could even try synthetic division with each one of those, and you would get a 0 for every single one of those. So, but again, get it down to a quadratic, and then factor, and that's all you have to do. All right, so let's look at another possible scenario. So here it says find all the zeros, and then sketch the graph. So we're going to literally start off with, if we do our P and Q, so all the factors of P, so this would be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And this is just plus or minus 1. So P divided by Q is literally plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. All right, so what we're going to do is find all of those using synthetic division. So we're going to start off with 1, negative 5, negative 5, 23, and 10. And then again, I typically start with my nice numbers like 1, negative 1, 2, negative 2, and then I start off with that. So, but you just pick whichever one you want and then try synthetic. So I'm going to try, let's just try 2 to see if it works. And we're going to plug, bring out 1. 2 times 1 is 2. This is going to give me negative 3. 2 times negative 3 is negative 6. That's going to give me negative 11. That's going to give me negative 22. And that's going to give me 1. And that's going to give me 2. And that's going to give me 12. So notice 2 is not a 0. And again, just to keep track of the numbers. So if I put 2 into the function, I'm going to get 12. So 2 doesn't work. You could try 1, negative 1, negative 2, 5, negative 5, 10, negative 10. Or you could skip around, but just make sure you cover whichever one you want. So I'm going to go ahead and try 5. Bring 1 down. I'm going to get 5. And that's going to give me 0. 0 times 5 is 0. That's negative 5. Add that. And then multiply. That's negative 25. That's going to give me negative 2. 5 times negative 2 is negative 10. And I get a 0. So 5, 0 is one of the zeros that I need to do. And notice what I found right now. So right now, x minus 5 is a factor. And 1x cubed, 0x squared minus, sorry, I started with x to the 4th. So this is x. So I had it right. So 0x, pencil. All right, so that's 1x cubed, because I start off with the fourth power. So this is 1x cubed, this is 0x squared, minus 5x, and then minus 2. So that's what I have so far. And then I'm going to keep using synthetic until I get it down to a quadratic. So now I'm going to take these terms, 1, 0, negative 5, negative 2. You could do the original terms if you want, but we already have it narrowed down. We're trying to get it down to a quadratic. So we want to start with these terms. We're going to use synthetic division with that. So I'm going to try, let me go back to negative 2. I don't want to lose track of the numbers. So I'm going to do 1. 1 times negative 2 is negative 2. Add that, that's negative 2. That's 4. That's going to give me negative 1. And that's going to give me positive 2, a 0. So I found another 0. Negative 2, 0. So notice now I have x minus 5 was a factor. X plus 2 is a factor. And then this is 1x squared, because I started off with fourth. And then I did synthetic, and it went down to x cubed, and then because I found another 0, this is now x squared. So minus 2x minus 1. And now if you try to factor this, it doesn't factor. But if you use the quadratic formula, you're going to find 2 zeros. So I know x equals 5 is a 0. I know x equals negative 2 is a 0. If you use the quadratic, you're going to end up with answers. You're going to end up with answers of 1 plus the square root of 2 and 1 minus the square root of 2. As a decimal, this is approximately equal to 2.4. And this is approximately equal to negative 0.4. Now, by the way, as far as the factoring is concerned, if I ask you to factor it, notice this was 5, and then I wrote x minus 5 over here. This is negative 2, so I wrote x plus 2. So it's always the opposite, or in other words, you're subtracting it. So when you get to these different answers here, so notice you're going to take x minus 1 plus the square root of 2, and x minus 1 minus the square root of 2. Because if I wanted to solve it for 0, I would literally just take the 1 over to the other side and take the square root of 2 to the other side. So that's why they're minus in there. So that would be the whole factored form of that original polynomial. Now to graph it, what we're going to do is plot these points. So I know 5 is a 0, and I know negative 2 is a 0, and the other ones is around 2.4, and the other one's negative 0.4. And then if you notice, we already talked about in behavior of graphing it. And so once we look at this, this is x to the 4th, and it's positive. So I know the in behavior is going to go up like this. And then I told you guys on an earlier lesson is check this interval here, and this interval there to see where the graph lies. So in other words, plug in like negative 1. So I would probably put negative 1 in this spot right here, and probably 0 and 1, and then probably 3 and 4 to see where those values lie to be able to graph it. So I found those numbers. If you notice my XY chart over here, I found those numbers, and then I plotted some of those points on there, and then I'm going to draw the graph to be able to sketch it to make sure it's more accurate. And so mine may not look the prettiest, but you can see that the in behavior is going up in both directions. You can see that it goes down and then back up and back down, and then the in behavior again is always to the right again. So I found all the possible zeros, I factored it, and then I sketched the graph to be able to do all that. And that's the polynomial. This is part 1 of part 2 for 3.4. So be sure you watch the second part